Okay, folks, I guess I need to talk about the scientific notation in 5.2. So let's jump to problem number 162. They give us 57,000. And so we're trying to turn that into scientific notation. So a little tricky. So 5.7. So you just want to take the first number and then put everything else beyond the with the decimal, and then you kind of ignore 0. So 5.7 times 10 to the, and how many places? So technically 57,000 is a decimal right here, right? So I need to move the decimal over 1, 2, 3, 4 places. So 5.7 times 10 to the 4th. Okay, that was a horrible explanation. So let's see, 5.7 times 10 to the 4th, that's 5.7, and then move the decimal 4 places in the positive direction. So we grab it here and move it 1, 2, 3, 4. I'm playing it backwards so you see what's actually happening. So whenever I do that little thing, that means there'd be a 0 there, a 0 there, a 0 there. 5, 7, 0, 0, 0. 57,000, which is what we started with. So probably would have been easier if they gave us scientific notation and told us to write it as a normal number. But they jumped straight into it. So I did it both ways. So hopefully you see the game a little bit better. So this is actually our correct answer. So they give us 57,000. They want us to write it as scientific notation. Okay. That was question A. Let's say we have question B. It says 0.026. Okay, so hopefully you realize it's going to be 2.6 times 10 to the something. Okay, so 2.6. So 2.6, the decimal needs to move 1, 2 places over, but to the left. So to the -2. And then double check your answer. So 2.6 times 10 to the -2. So just double check your answer. So write 2.6. And if you need to move it to the -2, you grab the decimal and move it 2 places to the negative. 1, 2. So the decimal goes there, and that becomes a 0.026. Same. Ta-da! Okay. So in 166 and 168, they had you play it normal. So I would have done the 166 and 68 first if I was writing this book, but I didn't write the book. Okay, let's try 170. 170, we have 3 times 10 to the -5th, 3 times 10 to the 9th. So rather than convert this to a number, convert this to a number, multiply it all out, what if we just focus on multiplying the 10 guys together and then multiplying these other things together? So what's 3 times 3? 9. And what's 10 to the -5 and 10 to the 9? If we multiply them, just add them up. -5, 9, 4. Aha! Okay, so that's why scientific notation comes in handy. Let's try the next one. That was 170. So let's try 170b. 170b. 7 times 10 to the -3rd all over 1 times 10 to the -7. Okay, so let's just focus separately on the 7 and the 1, and then focus separately on the 10 stuff. 7 over 1, 7 divided by 1 is just 7. Arr. And 10 to the -3 over 10 to the -7, just focus on 10 to the -3 over 10 to the -7. If I just focus on that, doesn't that sort of become, see, negative on bottom? A couple approaches. Maybe you're saying to yourself, wasn't it just -3 minus a -7, which is 10 to the -3 plus 7, which is 10 to the 4? So 7 times 10 to the 4th. That's probably the best way to do it. Cool. Okay, so those are the ones I forgot to do at the very end there, but now you can totally handle it. Sweet.